Welcome to Flawless Mathematics. Hello everyone. Yesterday I have already discussed about many one function. Okay, and in part number 1 we have discussed about what is function, the basic concept of functions and images, what is image, what is pre-image, etc. And in part number 2 we have already discussed one function, and in part number 3 many one function, right? Now our today's session is about onto and into function. Okay, what is onto function, what is into function, what is the difference between onto and into function, and how can you find which function is onto function and which function is into function. Okay, so let's start today's session. So first of all, what is onto function, right? So definition of onto function. So onto and into function. So definition, first of all, definition. Okay, we have to know the definition of onto and into function. Okay, so definition, onto function, definition of onto function: a function if maps a to b is said to be an onto function okay, onto function or a surjection. Okay, a surjection. Okay, surjection if what is the condition for being a onto function? That is, if every elements of B, okay, every elements of B is the F image, or you can say only image. Okay, F image of some elements of A, right, of A. Now what is image? So if there is, you know that A and B are set of elements, and if every elements of B, that means in the elements which are included in B, okay, which are included in B, so is the F image, that is image of some elements of A. Now A is also a set of elements, right? Now that is if f of A, that is f of elements of A, equals to B, or you can say range of F is the codomain of F, okay, in other words you can say it also. Now so here f maps A to B is a surjection if and only if for each B belongs to B. Okay, that means if you assume that element B that belongs to capital B set, right? So we conclude that thus F maps A to B is a surjection or onto function if and only if. Okay, IFF, that means if and only if. Okay, for each B belongs to capital B, where small b is elements of capital B set. Okay, so B belongs to capital B, there exist A, that's a element of capital A set, such that f of A equals to B. Okay, f of A equals to B. Okay, now what is into function? I hope it's clear that what is onto function. Okay, so after some time I will also show you some illustration. Okay, so before that you have to know the definition of onto and into function. So this is about onto function. Okay, this is about onto function. Now what about into function? So a function if maps A to B is an onto function, is an into function if there exists an element in B having no pre-image. Okay, no pre-image. If you still haven't watched the part number 1 and part number 2, then please go through those videos. Okay, because I have already discussed about these pre-images, f-image, elements, etc. Right? So pre-image in A, or you can say as simple as that if a function is an into function if it is not an onto function, right? So you can say in other words that if f maps A to B is an into function if it is not an onto function. It's very clear, right? If it is not an onto function. Okay, so that's all about the definition of into and onto. Now next I will show you some illustration. Okay, so some illustration. Now illustration number 1. So our first illustration, let me draw some figure. Now let me draw some figure. So first I take blue. So assume this is A set and this is B, and associated that if maps A to B, right? Now here A1, A2, A3 and A4, A3, A2, A1, A2, A3, A4 all are elements of A, and here B1, B2, B3, B4, these 4 elements of B, and you can say that B5 also the extra element. Okay, now A1 that maps B1, assume, and A2 that maps B3. Okay, now A3 and A4 both maps B4. Okay, both maps B4. Okay, and B5 and B2 are extra elements. Okay, now this is figure number 1. You can see. Now let me draw another picture. So this is you can say this is right x, and this is y, and the associated function is you can say g. Now x1, x2, x3, x4, x5. Okay, and here y1, y2, y3, y4, and here x1 relates or maps y1, x2 and x3 relates assume y2. Okay, y2, and x4 is relates y4, and x5 maps y3. Okay, now your question is, this is say figure number 2. Now your question is, which function is onto function and which function is into function? What is your question? Your question is, I am asking you a question, that is, in that two figure, which one is onto function and which one is into function? Okay, into function. So what will be the answer? Okay, what will be the answer? Just tell me what will be the answer. Okay, see, in figure number 1, see B2 and B5, okay, B2 and B5, okay, here if I write here B3, okay, and B5, B5. So here clearly B3 and B5 are two elements in B which do not have their pre-images in A. You can see that. Okay, here two elements, that is B2 and B5, are two elements in B which do not have their pre-images in A. B1, B3, B4. Okay, so B1, B3, B4, these three elements in B which have their pre-images in A. But B2 and B5, these two elements in B which do not have pre-images in A. See, so this F is an into function, right? Into function. Why? Because there exist some elements which do not have pre-images in A, and from the definition we must say that F is into function, because in the definition, see, a function F is maps A to B is an into function if there exists an element in B having no pre-image in A, okay. So it's clear that F is into function. Okay, so which one is into function? Our answer is F. Okay, now next move forward. What about figure 2? See, in figure 2 under function G, every element in Y has its pre-images X. See, here Y1 has pre-images X1, Y2 have pre-images X2 and X3, Y3 has Y5 and Y4 has X4. So under function G, every element in Y, that is Y1, Y2, Y3, Y4 has its pre-image X. So G is onto function, because from our definition we already knew that, see, every elements of B is the F image of some elements of A, right? So we can say that which one is onto function. So our answer is G. The function G is onto function, because under function G every element in Y has its pre-image X. So G maps X to Y is an onto function, and F maps A to B is an into function, right? Now I hope the idea of onto and into function clear to all of you, right? Okay, illustration number 2. So there are two sets. Let A -1 +1, 2 minus +2 -2, and the another B is 1, 4, and their associate two function, that is F maps A to B, a function, B a function, okay, B a function defined by f of x equals to x square. Okay, then your question is f an onto function? This is your question. Okay, this is your question. So what will be the answer? So here, if we draw figure, then you can say that f of A onto. Okay, so here is you can say A. So it's what are the elements of A? That is -1 plus 1 minus 1 plus 1 minus 2 plus 2. And what are the elements of B? That is plus 1 and plus 4, and associated function is f of x equals to x square, where x is elements of A, right? Now you can see that minus 1 whole square, that is plus 1, plus 1 whole square, that is also plus 1, minus 2 whole square, that is plus 4, and plus 2 whole square, that is plus 4. So you can say that yes, f is an onto function, because every element of B has its pre-images in A under f of x equals to x square. So your answer will be yes, right? Your answer will be yes. F is an onto function. Okay, what is the reason behind it? Because every element in B has its pre-images in A, right? Now your next question is if such that n defines n maps n here natural number. Okay, so set of natural numbers defined by f of x equals to 2x is defined is f an onto function. So what will be the answer? Just tell me. So your answer will be no. F is not an into function. Why? Because f of n equals to 2, 4, 6. Okay, so it's not, in other words, it's not of n, that is codomain. Okay, not codomain. Okay, because natural number into 2, that is it's not codomain. So it's your answer is no. Okay, or in other words, range of f is not equal to codomain of f, right? Now algorithm. Okay, algorithm. How can you find onto and into function? So algorithm, and this is the last point. And in next video I will teach you some NCERT problems. Okay, so algorithm. What is the algorithm? Step 1, step 2, step 3. Let's see. So first of all let f belongs to A to B be the given function. Okay, be the given function. Now step number 1. So step number 1 is choose an arbitrary element y in B. Okay, y in B set. Okay. Now step number 2. So I'm just write the steps step by step, right? Okay, step by step. Now put f of x equals to y. Okay. Now what about step number 3? So step number 3 is very easy, that is solve the equation. Okay, f of x equals to y, and for x, obviously for x, okay, for x and obtain x in terms of y. Now let x equals to g of y, Now step number 4, that is the step of conclusion. Okay, step number 4, that is if for all values of y belongs to capital B, the values the values of x obtained from x equals to g of y are in A okay, then f is onto. Why? Because if you saw that for all values of y, the values of x obtained from x equals to y comma g of y are in A. That means every element of in set B have their pre-images in A. So then f is obviously onto function. Okay, and if there are some y that belongs to B for which x given by x equals to g of y is not in A, then f is not onto. Okay, onto. So this algorithm you can write it on your copy. So I will apply this algorithm in the next video, where I will teach you some NCERT problem, and I will give you some solution of NCERT problems. Okay, so that's all for today's session. So if you want to write down, then it's go ahead. Please take the screenshot. Okay, definition of onto and into. Now illustration number 1, now illustration number 2, and there are 2 questions, then algorithm. Okay, then algorithm. So that's all for today's session. Okay, take care, bye bye. And one more thing, that is a special announcement for you, that I have already started a batch for class 12 mathematics. So if you were interested to join in my batch, then you can contact me, WhatsApp me in 750-148-9846 in that number. Okay, so take care.